Hi, and welcome to the EEAST beta version video simulation. This video is the first in a sequence of videos filmed in order to outline the EEAST procedures from start to finish in order to navigate a new user through the program. First, we'll start with an introduction. The model was developed at the University of Toledo by Dr. Daphne Poole, her water sustainability research team, Hannah West, and Chirjeev Anand. The EEAST models cost, energy, and greenhouse gas emission payback periods of decentralized water supply technologies. The technologies outlined consist of rainwater harvesting systems, composting toilets, and low flush toilets. The technologies are modeled in such a way to vary the end uses from outdoor to indoor and a combination of the two. These scenarios can be seen in the Scenarios tab here. This is a roadmap of the model. The video can be paused and you can dive into this a little bit more if you see fit. Moving on to the input page. The input page is comprised of several different colored cells. The cells of main concern for us are the yellow and the orange cells. The yellow cells are input parameters required by the user. The orange cells are calculated automatically by the model. Where I like to begin when modeling is the end use data section. This is where we enter our outdoor and indoor uses. Our outdoor use is irrigation area. Our layout has 0 viable irrigation area, so 0 is what we'll enter. For our indoor uses, you must select the building type. The building types are outlined here in a drop-down menu. Our building type is educational, so that's what we'll choose. Our expected occupancy in our educational building is 2,200. This includes faculty, staff, and students. Our toilet data, you can pick between standard and low flush toilets here. Standard toilets use typically 1.6 gallons per flush, where low flush toilets use 1.28. Our building design calls for standard toilets. Moving on to some of the exterior dimensions. Our design plans have a length of 300 feet, a width of 125. You can see that a number is automatically generated for the roof area. This is convenient when you have a rectangular building and one rectangle only with a constant length and width. Most of the time this is not the case though. We can go ahead and delete the length and the width and treat this as an input cell alone. For this reason, the cell is colored yellow instead of orange because you do have the option. We still have to enter the height of the building. Our building is 75.5 feet tall. This helps in sizing the pumps and pipes that are needed to distribute the rainwater that's going to be harvested. Along with the height, you need the stories for the same purpose. Our building is 5 stories tall. The number of toilets per floor, our building has 10 toilets per floor. Similar to the roof area numbers generated here, again you can see the cell is yellow. This is because most buildings don't have the same number of toilets per floor. In this case you can delete this and enter your own value. Again, you must keep the stories and the height parameters. Now that we have some building specifications, in order for a rainwater harvesting system to be analyzed, we need some rainfall data. That is where this expected collection data category comes into play. The collection data can be attained through this link, which takes you to the U.S. weather site. We already have that link up. We'll click it. We are in the state of Ohio, city of Toledo, and you can see some weather statistics are generated. What we are concerned with is this bottom row here, the average precipitation data. The easiest way to go about inputting this data into EEAST is simply get a pencil and paper, write them down, and then plug and chug. You can see we already had that prepared a little bit there, so we can just copy and paste and make this move along. Now the majority of the cells have been populated. You can see there are numbers. Moving on to some of the financial aspects of the input sheet, we're going to input our available project budget. We had a budget of $35,000. You can see that some loan requirements are generated here. This is based off of the total cost of implementation versus our budget. And the model automatically makes a decision via which one is less. Let's play with this a little bit and enter $40,000. You can see that a loan is not required for any of the scenarios. We'll move back to our original plan budget. Moving on to this cell, this is the pressure provided to the building. This again helps in pumps and pipes. Variable discount rate. We're going to choose 3. This can be played with in order to calculate your net present value and get a good understanding of the return on your initial investment once implementing any of the scenarios modeled within. Now that all the inputs have been changed, it's time to make some decisions. This cluster is your cistern specifications. This is a neat feature of EEAST. Your cistern height can be altered based off of some commercially available heights. We'll stick with 10. Now the reason why you'd want to alter that is for a landscape architect or your designer or building owner to essentially hide your cistern. You don't want a metal tank in your front, side, or backyard, so having an understanding of the dimensions will really give you a chance to lay this design plan out the way you want it and in order to achieve the aesthetics that you're looking for. Now that's everything in the input page. I hope that this was helpful, and we look forward to seeing you in the next video, which will cover the financial assessment sheet of these decision-based criteria that we've already entered. Thanks for watching and hope it was helpful.